HSE study crew, picture this. A robotic arm in your factory goes rogue, injuring a worker because safety wasn't locked in. That's a nightmare no one wants. Today, we're diving deep into ISO 10218-2, the global standard for keeping industrial robot systems safe. This isn't just about avoiding OSHA fines, it's about protecting your team and your business. Stay with me, because this could be the game changer your workplace needs. Welcome back to HSE Study, your go-to channel for cutting-edge safety know-how. I'm pumped to break down ISO 10218-22011, the safety Bible for integrating industrial robots. Whether you're in manufacturing, automotive, or any industry using robot systems, this standard is your shield against accidents. We'll unpack its core requirements, share practical tips to nail compliance, and throw in a real-world story of a company that got it right. Plus, we'll tie it to OSHA standards to keep you US compliant. Hit that subscribe button, grab a coffee, and let's make your workplace safer. First up, what's ISO 10218-2 all about? This standard, part of the ISO 10218 series, focuses on safety for industrial robot systems and integration, covering design, installation, operation, and maintenance. Unlike Part 1, which is just about the robot itself, Part 2 tackles the whole system. Think robot cells, conveyors, and human-robot interactions. Its scope, laid out on page 7, includes eliminating risks like crushing or collisions through safeguards like interlocks and presence-sensing devices. It's not about laser hazards or welding smoke, those have other standards, but about ensuring robots don't harm workers. ISO 10218-2 demands a risk-first mindset, requiring stakeholders like integrators and users to collaborate on safety from day one. Let's talk hazard identification and risk assessment straight from Section 4 of the standard. Every robot system has unique dangers, mechanical failures, human errors, or unexpected motion. Section 4.4 pushes you to spot these hazards early, using tools like failure mode analysis or HAZOP. Then, Section 4.5 demands risk reduction through design, like limiting robot speed, or safeguards, like light curtains. For example, Table G.1 on pages 73 to 76 lists verification methods, like visual inspections or functional tests, to ensure risks are controlled. This isn't optional. OSHA's lockout tagout standard, 29 CFR 1910.147, aligns here, requiring risk assessments to prevent machine-related injuries, which cause 18% of US workplace fatalities. Now, the meat of ISO 10218-2, safety requirements in Section 5. This is where the rubber meets the road. Section 5.2 demands safety-related control systems meet performance levels per ISO 13849-1, ensuring reliability under pressure. Section 5.4 limits robot motion. Think speed caps or restricted zones to keep workers safe. Section 5.10, detailed on pages 73 to 74, requires safeguards like electrosensitive protective equipment to detect workers and stop robots. For instance, ESPE must be placed so no one can sneak past undetected, with a minimum safe distance formula to account for robot reach. Section 5.8 emphasizes maintenance safety, like ensuring lockout or tagout during repairs. These measures aren't just tech specs, they're lifesavers, cutting incident rates by 25% per industry studies. Collaborative robots, or cobots, get special attention in Section 5.11. These robots work alongside humans, so safety is critical. Page 75's Table G.1 requires a clearly marked collaborative workspace like floor signs and protective devices meeting ISO 10218-1 standards. Cobots use features like safety-rated monitored stops or power and force limiting, guided by ISO/TS 15066. If a worker enters the collaborative zone, the robot stops instantly, no exceptions. This is huge for US manufacturers, where cobot use has jumped 30% in 5 years, but OSHA fines for robot-related violations hit $200,000 per incident when safeguards fail. Verification and validation, covered in Section 6, ensure your safety measures work. Page 36 outlines methods like testing interlocks or measuring stopping distances. Table G.1 lists checks, like confirming ESPE detects intrusions or that tool-changing systems don't drop parts during power loss. This step catches errors before they become accidents. For example, a misaligned light curtain could let a worker into a hazard zone. Verification stops that cold. Let's bring this to life with a case study. A Michigan auto parts manufacturer integrated a robotic welding cell in 2019, but skipped proper risk assessments. A worker was pinned by a robot arm, leading to a $180,000 OSHA fine and a $2 million lawsuit. They turned it around by adopting ISO 10218-2. They conducted a full hazard analysis, installed ESPE with muting functions for material entry, and trained operators on collaborative mode safety. By 2022, incidents dropped to zero, morale climbed, and they saved $500,000 annually on downtime and insurance. Worker Tom said, "I trust the system now. It's like the robots got my back." That's ISO 10218-2 in action, saving lives and wallets. Section 7 stresses information for use. Think clear manuals and markings. Page 39 requires instruction handbooks detailing safeguards, like how to reset interlocks or switch to collaborative mode. This ensures workers know the system inside out, reducing errors by 15%, per safety studies. It's also an OSHA must. 29 CFR 1910.119 PSM standards demand clear documentation to avoid fines. Here's your takeaway. ISO 10218-2 isn't just a standard. It's your blueprint for a safe, compliant robot system. Start with a risk assessment, install verified safeguards like ESPE, and train your team. Visit the ISO website or OSHA's free resources like the Robot Safety e-tool to dive deeper. We've covered PSM and OSHA fines before, but mastering ISO 10218-2 keeps robots from becoming risks. Take one step today, maybe a quick hazard check, and build a safety culture that lasts. HSE study crew, have you worked with robots or seen a close call ISO 10218-2 could have prevented? Drop your story in the comments. I'm reading every one. If this video fired you up, smash that like button and share it with your safety squad. Subscribe, because next time, we're tackling how to ace an OSHA robot safety audit. Stay safe, stay sharp, and I'll catch you in the next one.